Hello, Professor Waisin. We are Seminar 5 Team 2. I'm Keith, and together with Angie, Brian, Vaj, and Chenrui, we will be sharing about our database project. Firstly, do allow me to share about what a non-relational database is and how we implemented it. The more traditional relational database is basically a collection of information that organizes data in predefined relationships where data is stored in one or more tables of columns and rows. Each row in the table could be marked with a unique identifier called a primary key, and rows among multiple tables can be made related using foreign keys. On the other hand, non-relational databases are different in that they store their data in a non-tabular form. This could be documents, key value, white column, or graphs. The most obvious difference is that it has no rigid scheme, allowing for a great deal of flexibility. With that being said, the first benefit of non-relational databases is that they are highly scalable. Most relational databases are only able to scale vertically, which involves increasing the capacity of a single server. MongoDB, however, employs sharding, which is a method for distributing data across multiple machines. This allows it to employ horizontal scaling, which involves dividing the system dataset and load over multiple servers, adding additional servers to increase capacity as needed. Thus, expanding the capacity of the deployment only requires adding additional servers, which tends to be less costly. Next, non-relational databases also tend to be more flexible. A document can be highly detailed while containing a range of different types of information in different formats. This ability to digest and organize various types of information side by side makes them much more flexible than relational databases. They also perform faster because a query doesn't have to view several tables in order to deliver an answer. This makes it ideal for storing data that may be changed frequently or for applications that handle many different kinds of data. For the implementation of our database, we considered two factors, size and speed. For size, we want to minimize excess space, such as removing excessive intermediary collections. Alternatively, for speed, we want to consider the kinds of queries that will be performed and ask ourselves how can we structure the data to improve its efficiency. Also, are there any repetitive steps, such as data cleaning or formatting, that can be eliminated right from the offset? For our first collection, OE energy consumption, we first remove documents that we did not define as countries. Since they are not used in subsequent analysis, we can remove them altogether to prevent misleading outputs. Then, we converted the data types to what is appropriate for our use, such as years to integers. Lastly, we output this modified collection into a new output. For our second collection, we actually have both the energy export and the energy import collections. In this case, it is obvious that both collections are extremely similar, essentially having the same fields. Thus, we chose to merge them into a new collection, SG Energy. Since our queries require both collections, this will reduce repetitive lookup operations. The simpler aggregations that result also improve query time. Also, any aggregation pipelines can be more easily modified to fit different kinds of analyses. Lastly, we change the data type such as year or export values to integers. For our third collection, we had to first remove erroneous inputs for kilowatts per hour account. Then we reformatted this field to remove extra characters and converted it together with years and months into their appropriate data types. So, in summary, we have four collections for our final analysis: OE energy consumption, SG energy, household electricity consumption, and household gas consumption. Next, Brian will be sharing more about the questions. Thank you.
Thank you, Keith. Question 12 is about seeing how Singapore has performed in terms of energy consumption compared to other countries. We use population, GDP, and GDP per capita to find comparable countries to Singapore. Taking 6 time periods from 1965 to 2019, we then found 10 countries most similar to Singapore in the earlier mentioned categories in each period. By counting the overall number of times each country appears in each time interval for each category, we have identified the following countries to be similar to Singapore and use those countries that are boxed out. For countries similar in population, we can see that Singapore's energy per capita is rising, while energy per GDP is decreasing as compared to them. The trend for energy per capita can be explained by Singapore's significant increase in primary energy consumption. However, from the mid-2000s onwards, it can be seen that Singapore's decrease in energy per GDP is smaller than Lebanon's. Instead of the cause being a shift from manufacturing to a service economy, Lebanon's decrease in energy is mainly due to poor economic performance during the 2006 Lebanon War. For countries that are similar in GDP to Singapore, we can see that Singapore's energy per capita is rising drastically. This rapid increase is attributed to Singapore's relatively small population compared to the two countries. Whereas for energy per GDP, Kazakhstan initially had the highest values, but towards the end of the period, Singapore had the highest values. This observation will be because Kazakhstan suffered from the dissolution of the Soviet Union during the mid-1990s. This resulted in a drop in energy and GDP, with the decrease in energy being more. Lastly, for countries similar in GDP per capita to Singapore, we can see that Singapore's energy per GDP and energy per capita are both higher than USA and Ireland. Initially, the USA had the highest energy per capita among the three countries. However, Singapore surpassed United States energy per capita by a considerable amount after 1990. Singapore surpassing the USA is likely due to a small population, which is more than 60 times smaller than that of the United States. Comparing Ireland and Singapore, both countries have similar populations and GDP, but Ireland has smaller energy consumption. This difference explains why Ireland has lower energy per GDP and energy per capita. Overall, Singapore showed enormous growth in energy per capita compared to other countries listed. In contrast, other countries' energy per capita remained relatively stagnant. As for energy per GDP, it is noted that Singapore has the highest values at the end of the period, even though their decrease is the greatest. The enormous growth in energy per capita is a possible sign of concern for Singapore, as it uses more energy for each person, and Singapore relies heavily on fossil fuels. As an increased energy consumption from fossil fuels leads to more negative impacts on the environment due to more carbon emissions, Singapore has to ensure that it finds ways to limit the negative consequences. For analysis of various types of energy used by each country, we use share energy. The energy consumption was broken down into coal, natural gas, oil, other renewable energy, biofuel, hydro energy, solar energy, and wind energy. Lebanon and Costa Rica were excluded as the variables mentioned above were not found for these two countries. The two primary energy sources for Singapore are oil and natural gas. The other countries also use 3 to 4 energy sources. You can see that Singapore has been using more natural gas and less oil over the years. The change is because natural gas is the cleanest form of fossil fuel. However, compared to renewable energy, natural gas still produces more carbon emission and is worse for the environment. Yet, it also has to be noted that Singapore has minimal natural resources, making it hard for it to rely on the renewable energy sources to power the country. As such, this discussion leads to the question, why and how should Singapore change to cleaner forms of energy, which will be discussed later in the later questions. And now I pass my time to Chen Rui.
Thank you, Brian. I'm Chen Rui, and I'll be discussing whether renewable energy can adequately power continued economic growth. Renewable energy is defined as energy derived from sources that are replenished faster than they are consumed. Its use over time is represented by renewables share energy and renewables electricity attributes, which respectively stand for the share of primary energy consumption from renewables and the amount of electricity generated from renewable sources in terawatt-hours. Continued economic growth will be represented by the consistency of growth of the attribute gross domestic product or GDP with time. For this question, adequacy will be interpreted as using only renewable energy sources to meet energy demands. To study the impact of high reliance on renewables, we found the countries with the highest maximum renewable share energy from 2000. They are grouped into income brackets defined by the World Bank, and the top 4 countries from each income bracket are selected. We'll be approaching this question from 2 perspectives. The first perspective is that if GDP growth is impaired by high or growing renewable share energy, or if the short-term renewable share energy decreases or fluctuates significantly, then renewables are insufficient in meeting the energy demands of economic growth. A regression line is fitted onto the renewable share energy points to see its long-term trend. The graphs show that GDP is generally growing for countries with high or growing share of renewables energy consumption. The decreases in GDP are also found to not be caused by the rise in renewables share energy. For example, Iceland's stunted GDP growth in 2008 was attributed to a financial crisis, showing that GDP growth was not adversely affected by its high renewable share energy. Altogether, renewables are capable of helping to power economic growth. We also zoom in to see the short-term changes of renewable share energy. Here, we found moderate to strong fluctuations in renewable share energy of many countries, particularly the lower-income ones. Some countries like Philippines even show a consistent decreasing trend. This shows that renewables energy alone cannot cope with the short and long-term rises in energy demand, and countries supplementing their energy supply with alternatives instead. The lower and more unstable renewable share energy of poorer countries suggests that the high barrier to entry and development for renewable energy makes it less suitable to power economic growth for poorer countries. The second perspective looks at the consistency of electricity generation from renewables over the years. If it's stable, then renewable energy is a reliable and adequate energy source to power economic growth. The graph shows that only a few countries like Iceland and Ecuador manage a consistently growing trend of electricity generation from renewables, while countries with the most fluctuations span across all income brackets, for example, Norway from high income and Vietnam from lower middle income, and Colombia from upper middle income. The inconsistent electricity generation from renewables makes it inadequate to fuel economic growth alone, and this is faced by countries of all income levels. Overall, its unstable supply makes renewable energy unable to cope with spikes in energy demand, and this trend is observed to be more prevalent in lower income countries. Hence, renewable energy is capable of powering economic growth only as far as being a complement to other energy sources. Moving forward, these limitations can be mitigated by climate awareness driving state investments in renewable energy projects and research into making renewable energy generation more stable. This will allow renewable energy to be more adequate in powering economic growth. Now, Vaj should be covering the next question.
Thank you, Chenri. I'm Vaj, and I'll be explaining question 14. We aim to discuss whether Singapore should go nuclear. First, we looked into Singapore's sustainability goals to examine the possible role nuclear could play in it. In Singapore's sustainability plan, PM Lawrence Wong announced that Singapore will aim to achieve net zero emissions by 2050. To achieve this, Singapore's priority is transitioning from fossil fuels to cleaner energy sources, such as solar energy, with a target of 3% projected electricity demand by 2030, and hydrogen power, with a national hydrogen strategy of powering 50% of projected electricity demand by hydrogen energy in 2050. However, solar energy cannot replace fossil fuels as a substantial energy source due to its limited capacity and Singapore's limited land space, which restricts the scaling of solar energy. As we can observe from the dataset, although primary energy consumption is increasing, solar energy accounts for an insignificant proportion of this consumption, of a 0.077%. This is despite efforts to scale solar energy with an average of 86% across the years. Furthermore, hydrogen energy requires large-scale facilities for mass production, which poses a barrier to expansion given Singapore's limited land space. Hence, solar and hydrogen energy alone is insufficient to meet Singapore's sustainability goals. Therefore, we need to diversify cleaner energy options. One such option is micronuclear reactors. The compact size allows reactors to provide net zero emissions in remote settings for countries with small land spaces like Singapore. This aims to target issues Singapore faced in the past due to small land area and urban density. Furthermore, as seen from the data, there's an increasing reliance on imported natural gas in Singapore, causing energy dependence. Therefore, reactors can help diversify energy sources and bring about greater geopolitical stability. 20 reactors are able to generate substantial amounts of energy, equivalent to that of Tuas Spring Cycle Power Plant, while occupying minimal space and reducing greenhouse gas emissions. This was observed when we analyzed the dataset to study how utilizing nuclear energy over fossil fuels has impacted greenhouse gas emissions. We examined countries with fossil fuel and nuclear energy accounting for 95% of their energy consumption, when nuclear energy is 10% of their energy consumption. As observed from the data, a decrease in fossil fuel share and an increase in nuclear share was accompanied by a decrease in carbon intensity, and vice versa. This affirms the notion that nuclear energy can reduce greenhouse gas emissions. This is also recognized by the government, where EMA hopes that nuclear energy can power 10% of Singapore's energy by 2050. That being said, given the lack of practical feasibility in the past for Singapore for nuclear energy, it is vital to determine whether it's feasible to implement it based on land size and number of reactors needed. From the dataset, we first determined the number of reactors needed to provide 10% of Singapore's energy consumption. Based on 2020, Singapore needs 13,179 reactors. as each reactor occupies a 40-feet shipping container. By finding the area occupied by the container, we derive that these reactors occupy a small land area of 0.392 kilometers squared. Given that the land size of Singapore is 728.6 kilometers squared, the land size needed is negligible. Furthermore, given the economic and environmental feasibility of the reactors and negligible land space it occupied, this opens a window of possibility for Singapore to go nuclear. However, we have to take into account safety, as a minor accident can have a devastating impact. Furthermore, nuclear energy produces dangerous radioactive waste. Therefore, we need to further improve the safety of these reactors and look for suitable spaces to dump radioactive waste. Keeping all this in mind, nuclear energy is definitely a viable option for Singapore. Now, I'll pass my time on to Angie.
Thank you, Vaj. Hi everyone, my name is Angie and I will be going through question 15, which raised doubts about whether climate change is a problem. Firstly, skeptics have claimed that climate change is a natural phenomenon, citing that it could be due to the sun or it is a natural process not caused by humans. The second claim they have made is that climate change is not a problem at all, as it does not affect them in any way. To address the first skepticism, we will be looking at the greenhouse gas emissions from our world in data. We can see that there's an increase in greenhouse gas emissions over the years at a rate that is gradually steeper as well. So, when we look at some of the climate problems that is an indicator of climate change, for example, the land temperature, we can see a similar trend of rapidly rising land temperatures as well. Climate change doesn't just affect the land, it also causes the melting of ice and glaciers. From the sea extent dataset, we can see that especially for the northern hemisphere, the average ice extent has been decreasing exponentially over the years as well. The climate problem most of us are familiar with is the rising sea levels. With the melting of ice and the expansion of water bodies due to increasing temperatures, it is no wonder that sea levels are rising, as shown in this graph obtained from the CSIRO. So, after we have established that climate change is caused by human activities, some might still wonder, so what? The question of how it affects us enough for it to be a problem still exists. Well, that's why I am here to convince you. Climate change has led to frequent natural disasters, threatening the safety of our population. From our world in data, the exponential increase in weather events like hurricanes, droughts, and many more is certainly a worrying trend. Given the severity of such scales of events, it can lead to high death tolls and injuries. Another reason why you should be worried is because natural disasters can lead to economic damages. By destroying buildings and equipment, loss is incurred to repair these damages. As shown from the natural disasters dataset, the economic damages has been rising exponentially in recent years. Additionally, natural disasters also affect the insurance policies of the affected region. Take Florida, for example. It was hit by not just one, not two, but 3 hurricanes in consecutive years. The high insured losses incurred caused insurance companies to charge high premiums, making insurance unaffordable for the low and middle income. Lastly, increasing temperatures and rainfalls have expanded the areas that tropical insects live and breed in. Climate change has increased the occurrence of tropical diseases like dengue over the years, as shown in the global health data. Although it decreased between 2010 and 2015, we can see that the occurrence is set to increase again after 2015. Given that tropical diseases cause long-term disabilities, pain, or even death of more than 170,000 people each year, this directly threatens our health and well-being. By responding to the skepticism and showcasing the severe impact of climate change on our safety, wealth, and health, we hope to change the perspective skeptics have towards climate change. Climate change is no longer a matter of if, but when. Be the change you want to see and take action today. Although there have been efforts like the Kyoto Protocol and the Paris Agreement, simply reducing the increase in rates of emissions is not enough to minimize the impact of climate change. More regulations and sustained efforts must be done before we can see a plateau in climate problems like the rising temperatures, rising sea levels, and melting glaciers. With that, thank you for listening, and that is all from Team 2.